So in this video, I'm just going to go over the setup for Game 3 from the May 2020 LSAT Flex sample test. Okay, so we have 6 meetings that we're scheduling. 3 of them are going to be in the fall semester, and 3 of them will be in the spring semester. Okay, and then each one will be hosted by one of 5 cities. So we have 3 per semester, which makes 6 total positions, but we only have 5 players. Okay, so that's something to notice right away. It's just that we don't have a 1-to-1 ratio of players to positions. We're told that each city is going to host at least 1 meeting. Okay. Right, so that means that all 5 are going to be present, and so to fill that 6th spot, we're going to need one of the cities to be used twice. Okay, so one of our players will be used twice, every other one will be used exactly once, and no city will host more than 1 meeting per semester, so we can't have H twice in the fall, for example, right? And that holds for each one of our players and for our 2 groups. Okay. All right, so the first rule, if H hosts in the fall, then Montreal, or M, has to host in the fall. So if M isn't in the fall, then H isn't in the fall. Okay. One thing to note here is that just because M is in the spring, okay, it doesn't necessarily mean that it's not in the fall. So because we do have a player that's being repeated, this game doesn't really work like a traditional in and out game. Okay, so if you're familiar with in and out games, we have 2 groups, an in group and an out group, and each player is in only one of those 2 groups. Okay, so usually we can actually say that if a particular player isn't in one group, then it must be in the other, and if it is in one group, then it can't be in the other, but that's not the case here, so we have to keep these in their negative form. Okay, and those are our contrapositives. All right, rule 2. If V is in the spring, then T is in the spring, and the contrapositive. Rule 3, we have either M or V or both in each semester, so if we don't have M, then we have to have V. If we don't have V, we have to have M. All right, so that will get us V or M or both. Okay, great. All right, so I'm actually just going to go ahead to the questions now. This is the setup. If you want to try the questions on your own, pause here and check out my responses to the questions later. All right, so question 12. If the only meeting that Montreal hosts is in the spring, okay, so the only one that Montreal hosts is in the spring, that means that Montreal does not host a meeting in the fall, okay, then what could be true? All right, so we're going to start with our question-specific condition and just take it to its logical ends. All right, so if M is not in the fall, then H isn't in the fall either. H has to be in one of the 2 groups, right? So H will be in the spring. If M and H are removed, that means that all of the other players have to be present in the fall, right? Because we only have 5 players and we have to fill these 3 positions. So O, T, and V would all be in the fall. In terms of the spring, the remaining players O, T, and V, O could be in the spring. That's a possibility. Okay. V can't be because we don't have room for T. T can be though. Having T in the spring isn't a trigger. right? So we can't actually deduce anything from the fact that T is in the spring, so that's fine. That's actually going to allow us to avoid rule 2. Okay, so what could be true? A can't be true. We can't have H in both. T in both, yes, that's possible. So B is the correct answer. Okay, moving on to question 13. Right, if O hosts 2 of the meetings. Okay, so we do have one example of that here already, right? Because it's possible we could choose O here. So we can kind of use a previous acceptable solution there to sort of see what's possible. The question is asking what must be true, so we have to find something that's going to be true in an alternate scenario as well. So I'm actually going to try one. This one started with M in the spring, so let's do one with M in the fall. Okay, so what can we have here? So if H is in the fall and M is in the fall, can we split those guys up? Is that possible? So if we put, if we were to put H here, we would actually have to fill the remaining spot with V, right? Because if we don't have M, we have to have V, but putting V in the spring means T is also in the spring. So there's actually no way to split these pairs up in these scenarios, right? So we could put both M and H in the fall or in the spring together, and same sort of situation with V and T, but those pairs have to stay together. So E, T and V host meetings in the same semester. That must be true. Okay. All right, question 14. Which one of the following cannot be an accurate partial matching of the cities with the semesters in which they host meetings? Okay, so we're looking for something that must be false. So I'm actually just going to go through each of the answer choices and test to see if they could be true. If they could be true, then we have an acceptable solution that we can draw on potentially for further questions. And we've learned more about the boundaries of the game. All right, so the first answer choice, we have H in both semesters. Okay, so H is in both. If H is in the fall, M is in the fall. Let's see, we're going to need to have V, so we only need to make one work. That one works, so A is out. B, fall, so we have M in the fall and H and T in the spring. Okay, we need to have either M or V in there as well, and either one of those is fine. We're gonna have O here for sure, and then yeah, I mean we could have H, that would be fine. We could have T, there are lots of options here, so that's all possible. C, in the fall we have O, and in the spring we have M and T. We actually already have an example of that here, right? We have O in the fall and we have M and T as a possibility in the spring. So C is also possible. Right, D. So fall, H, and V. And in the spring, we also have V. So if H is in the fall, M is also in the fall. If V is in the spring, T is as well. And O would need to complete that. The issue, though, is that if T is not in the spring, which it isn't, then V shouldn't be in the spring either. Or sorry, if T, oh no, sorry, that's fine. Is there something wrong here? Is there something wrong with this one? Oh, I was trying E. So this one E is totally fine. I was anticipating that D is the correct answer because I've done this question before, but I tried E instead. So I'll show you why D does not work. All right, so D, we have fall, spring, there we go. In the fall we have H and T, and in the spring we have M. So if H there, then we should have M there. If M is twice, that means T can't also be twice. So if T isn't in the spring, then V shouldn't be in the spring, but then there's nowhere to put V. Okay, so that's why D is the correct answer. That's why D must be false. And here we just have a bunch of acceptable solutions. Okay. All right, let's do question 15. Right, so which one of the following cannot be in either semester the group of cities holding the 3 meetings in either semester? Okay, so HMT, that they can't be together in any of them. So I don't see why not. We could put HMT in the fall, as long as we don't have another M in the spring, then we would be fine. We could have VTO. So HMT, VTO, that's possible. Okay, so A is possible. Right. B, HM and V together. Do we have an example of that? Yes, we do here. That works, HM and V. So we know that it's not B either. C, H, O, and V. So if we have H, O, and V in the fall, we should have M as well. And if we have H, O, and V in the spring, we should have T as well. So that's not going to work in either semester. So C must be the correct answer. Question 16. If Tampa hosts 2 of the meetings, so we do have an example of that here. Which one could be true? So let's go ahead and draw this out as well. So T is in both. So if okay, so we can't know very much else. Let's see. Let's just create a couple of alternate scenarios here. So if we put V in the fall in this one and M in the spring, VT, we can't put H here, so that would have to be an O, and H would be here. And then we have our other example. So what could be true? H and V in the fall. So if we have H and V, that's not going to work. We should have M as well. So that would break rule 1. So A is out. B, M and O both host in the fall. So we would have T, M, and O, H, V, and T. So anything there. So V in the spring, T in the spring, H in the spring, and I don't see anything wrong with that, right? So we're not actually triggering anything here because M is in the fall and H is in the spring. Here we've triggered V in the spring, T is also in the spring, so that's fine. We have M or V, right? We have M in the fall and V in the spring, so yeah, that works out. So B is the correct answer. Question 17, last one. All right, so if H is in the fall, then we know M is as well. Okay, then which one of the following must be true? All right, so M is in the fall. We have an example here, right? So we could have H doubling up. We have an example here where O is doubling up. Does O have to host in the fall, right? So that is something that they have in common. Does Montreal have to host in the spring? B, no. Does Omaha have to host in the spring? No, we see an example here where that's not the case. D, Tampa hosts in the spring, so those are both also true. So let's see if we can make that false. So could we first, let's see if we can make A false, right? So it's a must be true question. So I'm going to attempt to falsify it. Okay, so does O have to host in the fall? Let's see if we can take it out. So instead we're going to have V or T in there, and here we're going to have both V and T. So yeah, I don't see any reason to believe that O has to be in the fall, so A is out. Does T have to be in the spring? No, I don't think it does. Actually, it does have to. So if V has to be in the spring, T has to be in the spring as well, right? But what we could do is we could actually have H, M, and V, and then we could have T in the spring with O and H, right? We could do that, right? So we can get around having to put V in, but we can't get around having to put T in because T has to be in the spring if V is. Okay, so no matter what, T is going to be in the spring. So the correct answer is D. All right, so hopefully that helps. If you have any specific questions that you want me to go over more slowly or in greater detail or clarify anything, yeah, just let me know.